Welcome to the Softwood Lumber Board, Mass Timber and Hybrid Structures, Outlook and Opportunity. My name is Nick Milestone. I'm the Senior Vice President for Strategy and Partnerships. I've been in construction now for over 35 years, spending 15 years in the off-site world of structural steelwork and the last 15 years in mass timber construction, both here in the UK, in Singapore, and in the United States. And here's a photograph of kind of explains my journey in life, where I've enjoyed low carbon construction, the use of mass timber, and using it in a hybrid construction. What is notable here is structural steelwork and mass timber are designed, manufactured, and installed within an eighth of an inch tolerance, which makes both materials symbiotic of each other. We can see the development of hybrid structures in the US market, the Rhode Island School of Design, the recent SeaTac Concourse D at Seattle Airport, the use of glulam and steel to create a truss. And on 901 E6 Austin, Texas, the use of structural steel frame with mass timber as the floor construction. The journey started for me around 2006, 2007 with the retailers in the UK wanting low carbon construction without compromising cost, thus the development of a hybrid structure which delivered both cost certainty and net zero carbon construction. We're starting to see projects around the world, notably the Mactan Airport in Cebu in the Philippines, where we can start creating form, curve and beautiful structures evolving with mass timber and hybrid construction. But what's really made the journey so exciting and accelerated the journey is over the last 10 years is the use of VDC, the digital twin. This creates the integrated digital delivery offsite virtually, which allows us to work in federated models where we can create models that are incredibly efficient and clash detected, which means when we come to do the actual construction, it's a lot more efficient. This takes advantage of the use of mass timber and light timber frame because we're in the realms of design for offsite manufacture and assembly, which involves green and sustainable technologies in building structure and the building physics and envelope, involving mass timber, steel and concrete. Thus, we create the hybrid material integration for site construction. We're starting to see iconic buildings now being constructed in the US, notably the Catalyst building, which was 150,000 square foot institution building for Washington Eastern University, by the use of glulam as the beam and stick solution with mass timber as the floor construction. Not just the cores and the lift shafts using mass timber, but also the pre-panelized external fabric using mass timber as well, developed offsite as a non-load bearing through wall solution. And here we can see how that works in a zero waste environment when we overlay the actual VDC with the actual construction frame itself. This was courtesy of Katerra, who built this project in 16 weeks as a structural core and envelope, which was a great success. But mass timber is not new. It's been in existence since 1866, especially glulam, which was commercialized in Central Europe in 1906, and glulam was first used in the United States in 1934. What's really disrupted the market is the coming to bear of cross-laminated timber from Central Europe, which was first used in the 1990s in the Austrian housing markets. It's been used for some years in the US market as an industrial mat. For the last 5 years, since 2016, it's now being used in the construction sector. When we look at the buildings constructed around the world, only 36% are pure CLT or mass timber buildings, whereas 64% are a hybrid use of mass timber, concrete and steel. When we look at the market breakdown, 69% are in the residential accommodation sector, whereas 31% is in the non-residential office and institution building typologies. Now, the impact of different building systems gives the great proposition for softwood. So why is the lumber industry interested in steel and concrete hybrid buildings? Well, from the overview you can see here, of the different building systems and types, the focus is on the amount of board square foot opportunity for the softwood lumber industry. So construction of single family detached homes has traditionally been the largest source of softwood demand in North America. But pre-pandemic demographic shifts and the socio-economic changes favor growth in multifamily construction. So what we've done is built the base case as a blended approach to the construction system used on whether or not a wood core can be utilized in that construction system. So our forecast assumes 25% of buildings are built with low wood use factors, 50% with a medium wood use factor, 10% of a high wood use factor, and 15% with a steel wood use factor. To realize the potential demand available in the US, the softwood lumber industry must adapt to these ever-changing markets and frame softwood lumber's value proposition around the present economic and market needs of design and construction professionals. Strong growth in taller residential and larger mixed-use buildings is expected to continue as North American cities increase density and encourage more livable community construction in urban core areas. This trend is both a threat and an opportunity for wood producers. It is a threat because steel and concrete construction has predominantly dominated building at greater heights than 6 stories. But it can be an opportunity if the building codes become more inclusive of wood and hybrid structures, which is why the IBC 2021 codes do allow for this, and wood systems are developed that can compete with steel and concrete for larger and taller building constructions. So what we see is by 2025, there will be approximately 745 buildings per annum using some form of mass timber. By 2030, the gain will be around about 2,400 buildings per annum, but by 2035, we see this just under 5,000 buildings per annum in US. So this is a great demand curve for US softwood lumber. But what we can see by example is the buildings around the world. Sky Headquarters, an 8-story building in London using pure mass timber with pre-panelized non-load bearing through wall system using lumber. International House in Sydney, and more recently in 2016, which started the journey, is Albina Yard in Portland, Oregon. The residential sector is embracing mass timber. The Forte Living building in Australia, Dalston Lane in the UK, but we've seen a lot of Brock Commons in Vancouver in British Columbia, which is effectively a mass timber frame built around 2 concrete cores. The education sector has really sort of embraced the use of mass timber, taking advantage of the biophilic properties of mass timber, which make it great working environments. The University of Amherst, the Macquarie University in Sydney, Australia, the GlaxoSmithKline Carbon Neutral Laboratory in the UK, and of course the Catalyst building in Spokane in Washington State. But it's the great work done by Woodworks in the US, which is helping to convert traditional buildings into the use of mass timber. There are approximately 1,000 buildings either being built or in design, and here you can see the spread now across the US. Now, the IBC of building codes, I've just come online in January 2021, which has allowed building types to go above 6 stories into the 8, 12, and 18 stories. The type 4Cs, the type 4Bs will be predominantly where the market will be, where we design these structures up to 2 hours, but we can maximize the exposure, the amount of mass timber being built. This is allowing the demand for both growth and height and type of buildings in the residential, non-residential sector using mass timber and hybrid structures. So what we can see now as a snapshot is the fact that light timber frame is working with CLT as a floor plate, NLT and DLT. We're starting to see structures above 6 stories, predominantly used in concrete, now going to CFS using steel studs. This is a great gain a great case for incorporating mass timber as the floor construction. There is the use of load-bearing mass timber. That's more seen in the UK and Europe, but with the development of steel studs, this will make a far more economic advantage and value proposition to developers. The long span market in the offices, we can use glulam, beam and stick. Typical spans around 25 by 25 foot. The use of structural steelwork in the same place, we can achieve spans of 25 by 42 feet, which means we can use shallower beam depths, bigger spans, but still using mass timber as the floor construction. I mentioned about how VDC works. It starts with the Revit model. Now, the Revit model can then be transposed down to the actual structural element analysis and the actual files themselves to create the CAD/CAM files for the machine data in automated production. So predominantly the steel and concrete industry uses Tekla. The timber industry from Europe is using CADWorks or HSBC CAD. Now they can come together with IFC file integration. Now the likes of Tekla Trimble are taking that to the next level to have one structural detail model that can incorporate steel, concrete and timber, which starts to make the whole journey far more seamless for hybrid construction. So if we take this building, the Cube, this was a 9-story over two stories of podium concrete with a concrete core, and then the adapt of putting in a structural steel frame and mass timber being used as both the floor and the wall construction, predominantly for the diaphragm action, both horizontally and vertically. Now, this building was constructed, just the timber and the structural steelwork, in 28 weeks using 5 men and 1 crane tower, which makes it very, very efficient. The UK construction model now has matured into a steel frame and CLT floors. We're seeing that more and more in the mid to high rise offices in London especially. So when we start looking at the future of mass timber, is the whole modular volumetric approach of having boxes or chassis being built off-site for student accommodation, for hotels and some residential developments. This has already been in existence in Europe since 2006 with the Journalists Hotel at the Winter Olympic Games. Volumetric is quite common in the US market. This is the ASC Hotel in Oklahoma City for the Marriott Group, taking advantage of light timber frame. But again, that would be only limited to physical building height by the use of what light frame can offer. To go above that, we can start introducing mass timber to go much, much higher. We're starting to see the use in mass timber service and lift cores. If you look at the service core, you can see the integration with mechanical, electrical being pre-installed off-site to make construction a lot quicker on-site. But where we're starting to see the market going much, much more is the development of load-bearing pod and panel structures, where we can use either light timber frame or mass timber used in the load-bearing pods. We can start using the floors, walls, and internal, external walls adapted with mechanical, electrical, and through-wall solutions with mass timber. This is how we will start to see the evolution in the short span accommodation market. And to close off, of course, is about building taller with mass timber. The Altasian software company building in Sydney will be 42 stories. It's a structural concrete core with an exoskeletal steel frame with the intermediate floors of glulam and CLT. Google's headquarter in London is a great use of concrete cores, steel frame and a CLT floor deck, and laid down it's actually taller than the Shard, and that will be built in the next couple of years. But more so now we're seeing the Ascent Tower in Milwaukee by Newland Developments, which is a great example, and taking advantage of the new IBC building codes to allow that to be built taller. That pretty much concludes this presentation. Please feel free to reach out to me and I'll answer your questions as best as I can. Thank you.